Alright, so what we're going to do is tackle a really difficult problem. This basically combines everything that you've been doing up to this point in acid and bases, if not more. We touched upon the Hasselbalch equation, which we worked 3 problems using. So you could be prepared to do the first third of this problem. Yes, first half, I guess. Anyway, let's go ahead and start this problem now. So what volume of 0.3 molar of HNO2 and 0.75 molar of sodium nitrous acid, nitrate. Yeah, nitrate. This is nitrous acid, this is sodium nitrate. Or, gosh, I don't know. NaNO2 must be added to form a 1.6 liter of solution buffered at a pH of 3.55. You can tell that this means pH. Given that K of A is equal to 4.5 times 10 to the negative 4. And, you should know. So we know pH, we know K of A. Oh, look, we should use the Hasselbalch equation, right? But what do we get out of it? The only thing we can solve for is the ratio between the sodium of the acid and base, right? Well, they give us the concentrations here, so what's the point of doing anything? I mean, you might think, oh my gosh, this is impossible. You're wrong. This implies dilution is involved. Remember, this says 1.6 liters involved in solution. 1.6. So, and it says what volumes are these? So what and times this will give you is equal to this times. So it's a dilution. So we can't use that because here, I'll write it out. P of H is equal to P K of A plus log the concentration of the base over the concentration of the acid. So how are we supposed to do this? Well, the concentration of the base and the concentration of the acid, this is after dilution. Because this is when both of them are actually in solution. They're not in a solution at this time. They're separate. And we're combining them to form a solution where the pH is at 3.55. Alright? So, we know that P of H, gosh, that is a D, not a P. P of H, we know, is equal to 3.55, right? But what about pK of A? Well, and if I keep on doing this will eventually drill into your head. So, the negative log of K of A is equal to pK of A. So, we do divide, well, no. Yeah. We're not solving for K of A here. We have K of A, we're solving for, 4.5 times 10 to the negative 4th. And that equals, let's find out, shall we? Alright, so 0.5 times 10 raised to the 4th. Alright, and then log that. And then negative that, so negative log of that, 3.35. 3.35. Alright, now we could just plug and chug now. So, 3.55 equals 3.35 plus, now, what I'm going to do here is say that the concentration of the base, let me say that here, or the concentration of the acid is equal to the ratio which equals X. Now, instead of writing this out, because there's no point, I mean, I'm just solving for one of these anyway. Or no, I'm not solving for one of these anyway. I'm solving for the ratio for both of this. I don't really care what these are, because I'm looking for the volumes. So why does it matter? Unless finding these will help me find this, then I'll probably write it out the entire time, but even then, I'll try doing this. It equals the ratio which equals X. So, log of X. I'm just doing substitution. Alright, so subtract this for both sides. I get 0.20 equals log of X. and then raise them both to the power of that, which equals x, which equals, alright, first subtracted by 3.55, doesn't really matter, raise that, 0.203 power, 1.596, 1.5, well, the calculator I used is 1.597, so let's just go ahead and use that, because I want to be more exact. I mean, yeah, it said 1.56, but I'm trying to be more exact here. So 1.597. Alright, so now we can make, so how does this help us with the ratio, I guess I should say? That would mean that the concentration of the base is this much times more than the acid. Can we write it? Let's write that down, though. Who knows, it might actually help us out on the run. So the concentration of the base is equal to 1.597 times the concentration of the acid. Which makes sense. Like, let's say this was 1.597 and the acid was 1. If we plug this in, the acid is 1, so that times that is that, so it's basically that. So, yeah, it makes sense to do this. Now, we know the total volume of this is 1.6, and the initial volumes of both of these is 1.6. So let's go ahead and write down that relationship, shall we? So the volume of the acid, I shouldn't write like that. The volume of the acid plus the volume of the base is volume of the base is equal to 1.6 liters. Alright, so now we have those two equalities settled. We know what equals to what. Now how does this help us in any way? Nothing. If we know what these two values were, then we would be set, but that's what we're solving for, so what's the point? Now, remember when I was saying dilution is involved in this process? What if we had two dilution equations written out and solve for that, shall we? And remember, this problem could be done a whole bunch of different ways. Alright, so, using a different color, let's go ahead and set it up. V of A, the initial volume of the acid that was added to the solution, times the initial concentration of the acid equals the final volume, which is basically the same as the total, times the final concentration. And I'm going to donate these, whatever you call it, apostrophes, calling them prime, which is the same thing as final. It's better than having to write a small subscript A and then a super subscript F. It's better to just do that, in my opinion. Alright, now in a different color, we're going to write out the same thing, but for the base, times that equals the final volume, which is basically the total volume, which times, yeah. Now, we could also say something here. We can say that this 1.6, because this is the final volume, right? The total volume is equal to V of A prime, which is equal to V of B prime. Because at this point, the volume of both is exactly the same because they're both in the same solution. So, the total. Volume total. So, all of this just to say the same thing. We only care about this, though. We only care about that. This is, obviously, we should know. But, I'm just saying. Let's go ahead and just separate that. No, separate this. Alright. So, this is all we care about. Right here. Okay, so let's go ahead and plug in what we know, shall we? So, do we know the initial volume? No. Do we know the initial concentration of the acid? Yes, it's 0.30. This is the acid, remember? This is the acid. Because it has an H at the end of it. We could just take out the Na, add the minus, and there we go. That's our base. So, 0.30 times VA. Do we know the final volume? Yes, we just established. Does it go to 1.6? 1.6. We do not know the final concentration, though. Now, we do the same thing here. Do we know the initial volume? No, that's what we're solving for. Do we know the initial concentration of the base? Yes, 0.75. 0.75 V of B. And like before, we know this is equal to 1.6, because this is the total volume, times, I don't know why I wrote A, it should be B. I was getting ahead of myself. You'll see why I did that. Prime. I'm just being lazy right now. Alright, so that's how it's supposed to be right now. Now, how are we going to solve this giant big mess? What I was thinking is that we would solve for the initial volumes of these and then plug it into this equation. But what good would that do? Because we have two different variables here. We would need one variable. Or an expression that connects both of them into one equality. Do we have such a thing? If we were like yelling madly at that, look at that one, yeah. It's this one. We use this one right here. I don't want to deal with fractions, so I'm just going to go, because this is basically m of b prime, and we already established this, right? Like, this is after dilution. So, these are primes. So, I'm just going to plug this in for the base here. So, 0.75 V of B equals 1.6 and 1.597 m of b prime. Alright? I'm going to go ahead and go over what to do next in the next video. I want you to think about it, though, before going to the next video. What do you think is going to happen next? I probably already told you, but it wouldn't help to think about it, and then after I tell you, you'll be set. Alright? See you in the next video.